Alright, so more of your exam questions are going to be where you get questions in context, okay? So all of this trigonometry stuff actually gets applied in real life situations, okay? So if you think about any things in context that have waves, okay? So analysis of sound waves, analysis of hydro waves, anything that has that wavy cycle, okay, that can repeat itself, well, it can actually be represented using your sine and your cosine functions, okay? And some of your mathematicians, engineers, all those sorts of people start looking into how you can apply it and how you can hopefully forward plan and generate future values, okay, based on the trig functions. So if you're given a graph in context, you can still answer all of the same questions that I've been asking you, okay? What's the amplitude? What's the period? And what happens if we change it, those sorts of things. So in this context, you've been given the distance over time, okay? And it's obviously tracking the distance of a waved function. So we can still generate what the amplitude is. So remember we talked about the amplitude is going to be from halfway to the peak or halfway to the trough. So the first thing that you have to do is find what that halfway point is. Okay, so if we think about the halfway point, so the halfway point of our function has to be halfway between the peak and halfway between the trough. So if my peak's at 0.9, my trough is at 0.4, I'm going to find halfway between them. So if you generate that, it's going to be at 0.65 because 0.9 plus 0.4 divided by 2 gives me 0.65. So this is actually the centre of my function. Okay, again, you don't have to sketch that horizontal line on, but you can. Sometimes it can make it easier. So now my amplitude is the distance from the centre to the peak or the distance from the centre to the trough. So I'm just trying to find the difference between 0.65 and 0.9. So the amplitude of this particular function is going to be 0.25 because that's that distance. Okay, so 0.25 is my amplitude. So if I have a look at the period, we remember that period is when the function repeats itself. So you can have a look at it and it's going to be from peak to peak or from trough to trough. Okay, so if I have a look, I'm going to go from trough to trough. So from 4 across to 12, okay, is 8. So therefore the period of this function, or when it repeats itself, is after 8 hours. Okay, so the period of this function would be 8 hours. Now, also, based on what your amplitude is and what the centre of your function is, so your vertical translation, and where your function starts, you should hopefully be able to generate an equation that represents this situation. Okay, so which starts at 1, sine or cosine? So which function starts at 1 if I was to graph a normal sine or cosine function? Cosine starts at 1, okay, so we're going to have a look and see if cosine will work out. So I know it's got to be the cosine, and I've got to put it in context, so it's cosine of t, and I'm finding what d is. We would put in our amplitude, and we would put in our vertical translation, or the centre of our function. So for us, our amplitude we worked out to be 0.25. Now you can put that in as 0.25 or you can put it in as a quarter. And then at the end, well, that's what our vertical translation is from our 0. So we've got 0.65. So I'm adding 0.65. Now, if you're not sure or you want to double check, then you can input in one of your coordinates to double check that it actually generates the correct value for you. Okay, so I'm going to just put in the cosine of 0. So if I put that in, so I've got a quarter of the cosine of 0 plus 0.65. If you put that into your CAS, it gives you a value of 0.9. Will?
Is that 0.8 of course?
No, it's 0.25. I just did it a bit small. Okay, so you should be able to have a go after that of question 5, 6 and 10. Okay, 5, 6 and 10 after that. Because then you can generate the equations, you can identify the period, you can identify the amplitude. It's just applying what you've learnt now with a little bit of context. Alright, so we've had a look at what happens when we multiply the function by something. We've had a look at what happens if we add or subtract something on the end. Last thing we've got to look at is if we multiply the x value by something. Okay, now the x value is your horizontal axis. Horizontal axis is all about when the function repeats itself, okay, because that's where it cuts through. So we're having a look at what happens if we make horizontal dilation. So if we squish it or stretch it horizontally. Okay, so we call that a period change because it's going to change when the function repeats. If we squish it, we're going to get more repetitions of our cycle. If we stretch it, we're going to get less repetitions of our cycle. So it works for sine, cosine and tan because they all have a period. Sine and cosine, their basic period is 2 pi. And for tan, it's just pi. So if we have a look, the period is going to be equal to your 2 pi divided by whatever you're multiplying your x by. Okay, so because we're compressing it horizontally by a factor of b, it's going to repeat b number of times as often. So, for example, if I had y equals cosine of 3x, then my period, or how often it's going to repeat, or what it's going to be stretched over, is going to be 2 pi divided by 3. Okay, that's what my period for that one's going to be. So what's going to happen is it's going to repeat 3 times as often as what it did before. Okay, so instead of having just the one cycle, okay, you're going to end up with multiple cycles. If we have a look, if we've got our x value divided by something, okay, you've got to have a look at what happens there. Okay, so if I did that, so if I do the same thing, so I've got my 2 pi divided by a half, because on 2 means a half. What happens if I divide by a half? It's going to double, good, because it's like saying 2 pi on 1 divided by 1 on 2, means we change it to a multiply, flip your second fraction, so you're going to get an answer of 4 pi. Okay, so it's actually going to double. Okay, so if we have a look at what that actually means for how to sketch our functions, if I have a look at my general function cosine of x, okay, so I've got my exact values, I've sketched that one on there. Okay, I've got no amplitude change, so my peaks are still going to be at 1, my troughs are still going to be at -1. If I have a look at what happens if I've got the cosine of 2x, well, my period is going to be 2 pi on 2, so which gives me pi. So what it means is it's going to repeat every pi. Okay, so 2 times as often. So before it repeated after 2 pi, now what that means is I'm squishing it up, so it's actually going to repeat every pi. Okay, does that make sense? So I had my original, it starts to repeat here. Now I'm bringing this point back, it's going to actually repeat from here. Okay, so if I have a look at how many times I brought that back, okay, so I brought it back 180 degrees, which means all of my other points are going to get squished that much as well. Okay, so the point here, I have to bring it back. The point that was here, I have to bring it back. Then you can put in your other points, okay, and put them together. Alternatively, you could just generate some more values for your table. Okay, so if I've got the cosine of 2x, okay, well 2 times 0 is 0. So then I'm just finding the cosine of 0, which is 1. Okay, 2 lots of pi and 4. Pi and 4 is 45 degrees. 2 lots of 45 degrees is 90. So I'm finding the cosine of 90, which is just 0. Okay, pi on 2. 2 lots of pi on 2 is going to be pi, which is 180. Cosine of 180 is -1. Okay, you can still apply your exact values to generate the table, plot your points in, connect them up to generate your function. Okay, so same as what we've been doing, you're just multiplying a different part of your function. So we're multiplying the number before we put it in. It causes a horizontal dilation, so it's either going to be squished or it's going to be stretched. Now, if you're multiplying by a whole number, it's going to be squished, okay? So it's going to repeat twice as often. So if I multiply like we did up here, so I'm dividing it by 2, which means I'm multiplying it by a half, means it's going to repeat half as often. Okay, so before it repeated every 360, so now it's going to repeat every 720. Okay, it's been stretched out. So I want you to have a go, see how you go with it. Page 303, question 2 and 3. That'll take us to the end of today, and that will be your homework due for me tomorrow. And we'll move on with phase changes tomorrow.